So shall we start our collection topic today? Yeah, it's already enough time. So we did discuss about all this stuff, okay? And then today's we have to jump to something called collections or that's the numbers. Yeah, I didn't share my screen. I'm just sharing it. Just give me a minute. Yeah, we can start with this from here onwards. Let's do it now. Okay, now you can see my screen, right? So after finishing strings, the next core topic we need to discuss is Python collections or data structures. This one. Because we did finish all our fundamentals and then we did finish string topic yesterday. We have very detailed coverage yesterday. Now let's get into the collections. What is collection? Types of collections. And then how to play around all that. Understanding the internal and external dynamics of collections. We need to understand all that. So what is a collection? Right? Collection is representing group of objects as a single entity. Right? So we have multiple values in one object, and that is called collections. Those values can be anything. Again, it can be a value like int value, string value, float value, or it can be a collection itself as well. So we can have collection of even collections as well. So that is a collection. Collection is a data structure, okay, or a object where we can store group of values into that data structure or collection. Okay, let's start with all these collections. We have this collections like the very basic one is bytes, and then we have something called Bytearray. So, and then we'll jump to the very important collection list. So this gives you very much this thing of, about collection. So let's start with bytes here. What is bytes and all that? But before that, all of you are clear, right? What is a collection? It's simple. We storing multiple objects into one. This thing is collection into one object. That object is a collection object. Collections means it allows to store multiple values into that. Okay, we'll see that with the examples very clearly. So the first collection is bytes. Of course, we don't use bytes and byte array quite often. We don't need much of these two collections, but I'm just introducing it so that in case if in any situation, if we need bytes or byte array, you can use them. But the concept is simple. After understanding string topic, all this will have a kind of similarity. Okay, because once we are familiar with strings, like that indexing thing, all that is almost similar to strings. But difference is string represent character data. But now whatever the collections we are using, they are used to store different types, heterogeneous data. It's not just only character data. Strings is more of storing a character data. It is used to represent sequence of characters, not sequence of different types of data. But when we talk about regular collections, they are used to store different types of data. Okay, so now let us get into the detail. Bytes, what is byte? It is the very core data structure, very basic data structure, and it is collection of values, simply speaking. And it is immutable. Immutable means we cannot modify bytes. And values must be within range 0 to 256. Bytes cannot store very big values. The range of bytes is just you can store integers from 0 to 256. That's all, not more than that. Okay. And it's homogeneous, means it accepts only integers. You cannot store string or float or anything else into bytes. Just bytes collection. And to create bytes, we use a function, a built-in function called bytes itself. To create bytes collection, you can see that. And this is how you create a bytes collection, and you pass any iterable object. That iterable object can be a string or can be a list, can be a tuple, can be a set or dictionary. Right? For constructing, we use that. After that, those values gets converted to bytes collection. All of you are following, friends. So this is a quick intro about bytes, about collections. Simply speaking, collections means they are used to store group of values of different types of data. Okay, and we already had discussed collections here. Especially we have different types of collections, sequential. Okay, and then three type of collections like set or dictionary. Okay, or non-sequential data structures. So now bytes is clear, right? Let's test this now. This doesn't have too much of discussion because we don't have methods inside bytes. So we are not going to talk about API of bytes, API application. I mean the methods of bytes. All these are classes though. Yeah, all these are classes, and only thing you have to remember is bytes is an immutable where it has a fixed length or range of values. Just it accepts only integers. It doesn't accept any other type. And we create bytes with bytes method. That we should remember. Suppose you open program, let's start creating some programs. I didn't post this program yet. I'll do that today into this thing. So now I should create a simple package here. Right click. Okay, new Python package.
Manohar, can you please share your screen?
I'm already sharing screen, buddy. So how about others? Shiva and Madhu and can you see my screen, or still do you have any problem?
Manohar. That's
You can
Manohar.
you
Yeah,
can
I
see.
can see.
I think Simha, you have some network issue.
Okay, I will reconnect.
Yeah, because others can see the screen. Only you have problem. Okay. So now I think there is some issue for Simha. That should be okay. So now what we do is let's go to this and create a new and then Python file, and then create what shall we create? Name this as Python collections and data structures. Enter. Now we can see here. Let's create a simple program. What is that? We are talking about bytes. Okay. Now let's create simple bytes program. So something like some data equal to some bytes up. You can create. This is the how you have to create a bytes collection. Just pass a list. We'll talk about list in just a few minutes. Today we are going to get introduced to list as well. 1, 2, 3, 4, 5. Okay, and then you can print this bytes collection. Right click, and then run this. You can see, of course, bytes internally stores data in hexadecimal format. You can see this. Okay, because this is more of a core data structure where it tried to store data in this format. hexa format. X, whenever you see something X in data, then it is a hexa format. Sorry. So we just try to create bytes with bytes data type, and we're passing a list of values. And then you can see that that list gets converted to bytes internally. And when we print it, you can see that this is the bytes collection. And suppose I want to extract data from bytes. There are a couple of things you need to test here. One, what is that? Bytes is immutable. You cannot modify it. And it has a range of values 0 to 50 to 56. Okay. And it accepts only integers. Now you can test all these properties, characteristics. Suppose you see that. So in these bytes, I try to insert 257. I'm just testing just to show you that what is that bytes accepts, what it doesn't. Now you run this and see, and you can see it's throwing error. What is that? Bytes must be in range 0 to 256. So it has a fixed range. We cannot add more values, less values. So that is important observation. Next up that it allows only integers. Suppose let me try to add strings, something like, okay, 1, 2, 3. It is a numeric string. I'm trying to add it to bytes. Now right click and run this now. And again, we have another. String object cannot be interpreted as integer. We have a type error when we try to pass string into a byte collection. So that is so we have a type error here. See that. So bytes allows only integers. So this is homogeneous. What is that term? Homogeneous means a data type which accepts only same type of values. And for bytes, it always accepts integers, no other data. And if you try to add, it throws error like this. You can see that. Okay. Next after that. So once we do this, the next thing, immutability. How do you test immutability? Suppose this is a bytes collection. Now we had already discussed about strings and everything, right? So now I want to extract a value from bytes. Then this bytes has an indexing. By default, these are all sequential data structures. Even bytes is a sequential data structure. Okay. When a data structure is sequential, such data structures always have indexing. So what is that? In Python, sequential data structures have data structures have index. Okay. So when we say they have indexing, that indexing is both forward and backward indexing. Okay. Now if you see the example, right, you can see that these bytes have indexing, and you can see that there 0, 1, 2, 3, 4, 5, a positive indexing and a negative indexing. We have both types of indexing for any sequential data structure in Python. Okay. So suppose if I want to extract any value from bytes, then I can use this indexing. I can apply slicing. Even we can do slicing on this. Okay. Whenever you see that data structure is sequential, what different things you can apply on that? You can extract that data through these indexes. That is one thing. Second thing, you can also apply slicing on these data structures. Why? How I can apply slicing? Because this has indexing, so that you can also apply slicing on such data structures. So what do you do right now? Open this, just try to print. Okay. I'll just show you. Data of some 0. Similarly, if you want, you can print few more values. You can see this. So data of 0, data of 1, 2, 3, 4. So this is extracting. I don't think yeah, it's starting from 0 to 4. Exactly, we have 5 values, and index starts with 0, ends with size -1. Now, let's run this now. Now you can see that all that values are displayed in readable output. Suppose when we store into the bytes collection, internally data is stored as hexadecimal form. But if you print it, still we are seeing output in a readable format. This is one scenario, how to extract value from bytes, how to create bytes. And that another important information is how this indexing is created for this bytes collection. Always it starts with 0, the index, and ends with size -1 or -n to -1. If total size is 5, it starts with -n, -5 to -1. Okay. So now we have observed, tested if it accepts heterogeneous data or homogeneous. And we also checked if it allows any value other than this 0 to 256. We should check immutable. Immutability means we cannot modify this data structure. So immutability means that we cannot modify that data structure. And if I should modify, what is that I should do? Generally we have to convert it to any other type. Then we have that mutable type, and then we have to modify it. That is the choice we have. Other than that, here we cannot modify it. It's not, we cannot change it. Okay, so let's test it. So you can see here, extracting elements. Just now we tested, extracted each element with index. We can also apply iteration using this for, right? Suppose I want, instead of printing one by one, so this is extracting. Okay. Extracting, sorry, using index. Next, we can also extract values and iterating this bytes. Iterating bytes. So how do you iterate it? Just for value, okay, in bytes. So what is the name? Data. The name of this data type is data. And then you can print each one. Just simply say print value. If you want, you can add description to that. And just run it down. Now you can see we have output displayed 2 times. You can see here. Right? So why 2 times? First time when we printed with all these prints. Second time when we iterated that bytes collection with for loop. So these are 2 different ways of extracting data from the bytes collection. Now the third thing is I am trying to check. I am testing immutability. Okay. So what is immutability? I am trying to modify a value in bytes. Let us see if it allows that change or modification. Okay, let's do that now. Some data of 0. I'm trying to modify 0th element in that bytes collection. I'm setting this instead of 100. I'm assigning this data of 0 with 100. I'm trying to modify this location of bytes collection. In this 0th location, I am trying to assign 100. Means the old value, whatever we have, 1, it should be replaced with 100. That is my expectation. But let us see that. I don't think this is going to happen. Print data, data of 0. Because bytes is immutable, this change is not allowed. And it throws error. Right? Let's run this. You can see that. You can see the error in the beginning itself. What is the type error? Bytes object doesn't support item assignment. As the name says, this assignment is not possible with bytes. Doesn't allow that. All of you are clear with this, friends? So this is the idea. What is the idea? Bytes doesn't encourage any item assignment because it is immutable. As it is immutable, you cannot change that bytes. So this shows, this is a clear proof of what is that immutability, that bytes cannot be modified. All of you are clear? So this is overall idea of what bytes collection. We understood what is bytes now. It is a sequential data structure. And second thing, we also understood that we can create bytes with bytes method, and we can pass any iterable object here. Iterable in sense a string or a list or tuple or dictionary or anything. But of course, that gets converted to bytes back. Don't think, and also of course, generally for bytes, I don't think it accepts string other than integer data. A small correction to my statement. Generally, I'm just only saying what is iterable object. But for bytes, it always accepts only integers. That too 0 to 256, not more than that, less than that. You got it right. For this bytes, I don't think we can create it with the string object. We can pass strings to bytes as it is purely homogeneous. Okay, and then extracting, generally we do that with the indexing like this. And then iterating we can do just with for loop. Like we are doing this number of times every day. By now you should become familiar with for. And we are testing immutability. Generally, we cannot modify bytes. So you can comment this, but now you can remove this because this is a bad idea. Modifying bytes is a bad idea. Finally, this is overall conclusion or summary of bytes. Okay. So, and even bytes is sequential data structure. It also does have indexing like with positive and negative as shown here. Okay. And finally, we did tested all different characteristics of bytes. So this should give a clear idea of any collection. If you understand this, these properties are same for any sequential data structure, not just only for bytes. Okay. Now after that, we are moving to the next collection, byte array. So both are same. Bytes and byte array are almost same or identical, we can say, except bytes is immutable. Which one? This one. Bytes is immutable. You can see that. Okay. Whereas byte array is mutable. We can modify byte array, but we cannot modify bytes. That is difference between bytes and byte array. You got it right. So which is mutable? Byte array is mutable. Which is not? Bytes is not mutable. It is immutable. So that is difference between bytes and byte array, friends. Clear now? Let's test this as well. Now let's get into the another example. What is that? So I created it as Python data structures. Okay, just a minute. Let's create Python package, Python collections. Okay, and then let me push this into the collections folder. Refactor. And also I'm changing the name as again refactor. I'm renaming it to Bytes collection. Okay. .py. So that makes more sense for us. Okay. So this is all the program, the characteristics, everything. Let's take another example. New Python file, Bytearray. I put it as demo. Okay, we are trying to understand Bytearray. So let me name it as demo, friends. Enter. So now just create, this is also a Bytearray when we talk about it. Even this is a sequential data structure. All whatever we are discussing till that tuple, all data structure or collections are nothing but, what is it, friends? They are sequential data structures. Okay, now let's create Bytearray, something like, data list equal to. So you can just say Bytearray. You can see that it is clearly visible in IntelliSense. Copy, take that. And then all other properties are same. Even Bytearray is homogeneous and Bytearray has a range of 0 to 256. Remaining all characteristics are same as bytes. Only difference is Bytearray is mutable, whereas bytes is immutable. So even this also accepts only integers. So you can print it and see that. Okay. Now you run this and see. Let me, where is the right click and run this now. Data list, right? I have to use new data list, right click and run this. And you can see that data inside Bytearray. Again, it is stored as this one, like hexa form. Okay, because these are used mostly for low level representation of data. This bytes and Bytearray. Okay, so but all other characteristics, if you look at this, it is also same as this. What is that? It is mutable, but the range thing and the nature of accepting data. It accepts, even Bytearray also accepts only integers, not any other type of data. Suppose you see here, I try to store string in Bytearray. Let's see that I just use numeric string. You can pass anything for testing. Okay, any string for testing. So let's run this and you have an error because Bytearray don't allow any other data other than integers. Okay, this accepts only integers. That is one thing. Next thing, what is second thing? Let's see that now. So the range factor. Suppose I try to insert 257 into this Bytearray collection. Now run this. Now you can see that again we see an error. And it's clearly saying here, what is that? Byte must be in range of 0 to 256. So that shows that byte, the range of values we can pass to this byte array should be 0 to 256. Okay. And then next, the third characteristic is mutability. So only thing is this is mutable. You can say something like data list of some 0 equal to, I put 100. I'm trying to do item assignment. When we do that, this value in 0th index is assigned with this 100. Right now, the value in 0th index is 1. So I'm trying to assign that with 100. So that if it is updated, then it means it is mutable. If it is not allowing that change, it is immutable. You got that, friends? So let me run this now. Let me print it. Print data list again. And right click, run this now. And you can see that we got error, not error. This belongs to which one? This one. Let me remove this 257. Because the range of bytes is 0 to 256. The issue is with that out of range value. Okay, so Now I removed that. Let's test it. This is allowed because bytearray is mutable. So I'm doing an item assignment. So definitely this would be allowed in bytearray. Let's run it and you can see that the change happened. But internally, if you print bytearray, the data is encrypted into hexa format. If you want to see it in readable output, either extract with index. So you can just say print off. So what is that? You are printing or reading data from where? From data list. That is bytearray. How do you read it? Data list of 0. That is the value which we modify. The value in this 0th index. And the indexing, everything remains same. You can see here, any sequential data structure has a similar indexing. It starts with 0, element starts with index 0 and ends with size -1. If it is positive indexing. If it is negative indexing, the index of element starts with -1 and ends with, minus n and ends with -1. So that this is quite common because that is how Python operates. Okay, so now even this has indexing. So we are trying to extract a value from 0th index and see that. Let's run it now. And you can see that this time we are seeing 100, but we are not seeing 1 in that 0th index. You can see that. Okay, so if you want, you can print more values. Just copy this and print it. So 1, 2. If you want, you can print all values in that data structure. And this has indexing 0 to 4 or -5 to -1. Suppose I'm just quickly showing you. There are few more important scenarios. So checking boundary of a collection, especially sequential data structures. Okay. Suppose I'm trying to print a value and the index I am passing here is some 5 itself. What is the index? I'm choosing 5. Do you think this index 5 exists in this data structure? Just see that. We don't have index 5 in this data structure. It starts with 0, ends with 4. But I am trying to access a value from 5th index. Suppose if I run this, what is that it happens? It leads to index error. So these are important checks you have to keep in mind when you play around with this kind of data. You got it right? So second scenario. So this is one scenario, right? Trying to extract something, this one. Right? Out when the value is not, if that index don't exist in a collection, it throws index error. Keep this in mind, friends. The important scenario. Okay, so make sure you are trying to extract values within the boundary of that collection. Don't go out of that boundary. Else it leads to index error. This is very important. Understood now? So that's all about this. Suppose you take another example. This doesn't have a negative indexing, right? So suppose what is that negative indexing? Yeah, I think we have negative. Sorry. What I am trying to test is a correction to my statement. We do have negative indexing. This starts with the, let me just add indexing here quickly. You can put hash 0, 1, 2, 3, 4, 5. This is the indexing. 1, 2, 3, 4. And we don't have index 5. So that is what we are checking now. And these values starts with the negative index. So what is that? -5 and then -4, -3, -2, -1. That's it. So suppose I try to extract a value from negative index -1, it is fine. Suppose I try to extract from, instead of -1, I extract a value from -2. Do you think this index exists in this collection? This is what I want to show. That index always, negative index starts with -1 or from -n to -1. We don't have anything beyond -1 in any collection, not just this. So I try to extract something from -2. This is an illegal index. This index don't exist. This is illegal because why illegal? It doesn't exist. And you are trying to access element from illegal index, which is not allowed, which is not legal to do. Okay. So this is also illegal. When you run this, right? Of course, the program terminates from this line itself. You know, right? Python executes line by line. Once it comes to this point, it runs into error. Then automatically it will terminate from here itself. I don't think this statement gets executed. Anyhow, let me run it again just to show you that. So what happened? We are able to print these first three values from 0, values from 1 and 2. Why we are seeing 100 instead of 1? Because we are doing item assignment at line 8. So that's why what's happening here. Instead of 1, it's printing 100. And similarly, what else here? You can see here, we are also testing the boundary of any collection. You can see that. It just terminated from here itself. So what do? Is I just try to print some 3 from here, the value from third index, which usually exists here. You can see 3 exists. And negative index always ends with -1. We don't have anything beyond -1. Keep that in mind. And now you come here, you see here. I am extracting something -1, till that it's okay. We don't have a problem. But extracting from -2 is not legal. It's illegal. Let's run it now. And it should throw error for -2. It's not throwing anything, of course. So I just add something here. Testing. -2 index. Sorry, -1. I think we have -2, right? So -1 until -5. Okay, sorry. I just took a, I have a different thought in the mind. Okay. So what I want is, I want something which goes beyond the index, like, beyond index in sense, -6 or -7. That is the idea. Yeah, -2 exists. That's why we don't have error. Okay. Instead of -1 to -5, I want to go beyond that and test it. Okay. So the idea is not -2. Let me do one thing. You can test for -6 friends. Sorry. I think so. The idea is testing beyond boundary. So -2 exists. So please ignore that correction to the statement. What is that? So now I had gone to -6 and I am testing it. So this is illegal, not -2 friends. Sorry, this exists inside this collection. Now right click, run this. You can see that you should see an error. This is what the idea is. So when you go beyond boundary of any collection, it leads to index error. And the common error with this kind of sequential data structures is it runs into index error. -2 is not beyond indexing. It exists, friends. From -1 to -n, right? Or from -n to -1, it exists. If it goes beyond that, it throws index error, just like what we are seeing. And that I want to show to you guys. Okay. So not the idea is, I think here it should be something out of index. So did I make it clear for all of you? Make sure you are following a healthy boundaries when you are trying to access data from any sequential data structure. And subject to the correction, what is that? It's not -2, which I was testing here. It should be -6. A boundary that don't exist, simply speaking. Okay. And -2 exists. I just was thinking a different thing in the mind. Okay, I was having different thing. Okay, so this one. Okay, finally, this makes clear for all of you. All of you are clear on this about bytes and byte array?
Yes.
Sorry, friends. So once if you are clear with this, let's just maybe you can also test it if you want. Let me share this with you. So what is it now? You can test it. I'm just sharing the code with you. And similarly, even you can try this code and test it, bytes thing. Okay, now this is totally fine. Now we are going into actually we are stepping into the actual collections. Of course, these are not imaginary, but even these are also important. But only FYI for your information, we don't use much of bytes and byte array. Very few cases where we deal with a kind of encryption. Suppose we need to encrypt data. In such cases, we prefer bytes and byte array. Other than that, we don't prefer this. Also, these have just a simple range of 0 to 256. We cannot store beyond this 0 to 256. So again, there is a limitation for these data structures. We cannot store how much ever data we want, whatever the range of data we want into bytes and byte array. So these are the limitations for them. Okay. So now finally, we can jump into the next topic. And we did discuss many scenarios associated with collections. What is that? What did we cover till this byte array? We understood what are these sequential collections and then how the indexing exists for them, and then extracting through index, iterating using a loop again. We also tested that iterating through loop. Okay. And then we understood about the extracting data from each index of that data structure and also testing boundaries of these data structures. So all this, which is legal, which is illegal, right? Generally, when you try to extract out of bounds, any value out of bounds in that collection, it leads to index error. That these are all important observations. Now let us get into the important this thing, that is the list.
The
This
only
list
difference
and
is bytes and bytes array. Bytes is immutable. Bytes array is mutable.
correct. Bytes is immutable. Byte array is mutable. Correct, Simha. Yeah. Do you want to ask anything?
Yeah, that's it.
Yeah, yeah. Oh, you are adding one more point for summarizing. Yeah, bytes is when we talk about bytes. So byte array is mutable. We can modify byte array. Bytes is immutable. We cannot modify bytes. So these are differences between bytes and byte array. Now getting into the important thing, that is list. What is list collection? And this is something we use a lot in programming, a lot in development. You cannot imagine at least 90% of the cases without list. No matter what, if you use direct lists or if you use even what is that the advanced libraries like pandas, numpy or anything, the important thing is the underlying data structure. List is one of the core data structure which is very much used in real programming. Okay, now what are the characteristics? Again, we have to see the characteristics of each collection. List is dynamic. Dynamic means it is growable and shrinkable. You can add values and you can remove values. If you add values, it increases, it grows. If you remove values, it shrinks. It's like an elastic balloon. If you put air, it expands. If you remove air, it contracts. Right? Same thing applies for list also. Dynamic in sense, if you add values, it grows. If you remove values, it shrinks. So that is the nature of dynamism. Heterogeneous, unlike bytes and byte array, a list accepts any type of data, not just only integers. If it is bytes or byte array, they allow only integers. We tested that. We are going to test here, even for list. List is heterogeneous. In sense, it accepts different types of values, not just only integers. And insertion order is preserved. As these are sequential data structures, very important point. They preserve insertion order. Preserving insertion order means in whichever the order you pass values, in the same order the values are extracted or printed or they are read from that collection. So that is the meaning of preserving insertion order. Duplicates are allowed. Yes, we can pass duplicates in all these sequential data structures, starting from bytes, byte array, and then list and tuple and strings. Any of these sequential data structures allow duplicates. And we'll see that as well. We are going to test it. There is a famous interview question. How do you remove duplicates from a list? We will also see that small programming scenario. So these are the characteristics of list. Another very important characteristic which you are not seeing is list is mutable. What is that? We can modify elements of a list. You got it? It's not like you cannot modify. You can modify list happily without issues. There is an immutable list that is nothing but called tuple. But we cannot modify tuple. But list we can modify. So these are important characteristics. Okay. And how do you create list? We can create list in two ways, either with directly using an operator index like this, the square brackets. Declaring all your values in square brackets makes it a list. Or else there is a method called list itself. We use that list method. We'll go one by one. Let's not rush everything in one shot. You can see here. These are important characteristics. So what is a list here? A list is used to represent group of objects as a single entity. Of course, we can place different values in a list, but when you print it, all that values are shown or are presented as a single entity, as a single object. Okay, these are all important observations. What is that? Now, after this discussion, is list mutable or immutable? It is mutable. Is it dynamic? Definitely yes. Is insertion order is preserved? Yes. Does it allow duplicates? Yes. Is it homogeneous or heterogeneous? It is heterogeneous. It's not homogeneous. It allows any type of data. And definitely like any other sequential data structure, list uses indexing to perform operations on list. Okay, if you want to add anything to list, remove anything from list. If you want to modify a value in a list, right? Or if you want to extract some value from a list, for everything, to do any of these operations, we need indexing. Okay. So that is important thing we should observe. And also another important thing, for any of these sequential collections in Python, we have this forward and backward indexing or okay, that are positive and negative indexing. And which one you want to use or you want to use both combined, it's up to the developer or the engineer. Okay, whoever try to implement that, they can follow whatever they want. So these are the important characteristics of list. Following friends. So this should be clear. Then we will try to create a list and test all these characteristics. We'll prove these characteristics that it is mutable, it is dynamic, it preserves insertion order, it allows duplicates, it is heterogeneous. We are going to test all these features. and get some idea. Okay. And how to create a list? We can create it in two ways, either using this index operator, that is this square brackets, or using a list method. Suppose if you want to create a list with this index, we just create with square brackets, and this creates an empty list. And if you ask me a question, can we have empty list? Answer is yes, we can have empty list, not an issue. Right? And if you declare any list, you can see that this is a list of integers, you can see. Okay, if you create a list here, this is internal representation of list. This is how list is created, and we have indexing and like this positive indexing 0 to size -1, negative minus n to -1. Understand? So this is the internal representation of list. Okay, we'll go from here onwards. Extracting. How to extract a value from list? Simple. We extract through index. Simply you can see that list name of index. Of course, till when this index can be applied wherever that indexing is legal. Okay, not beyond that index that exists inside that data structure. For positive side 0 to n-1 we can apply. For negative side -n to -1, not beyond that. Like n plus 1, n plus 2, minus n plus 1, minus n plus 2. So, right, you cannot apply that. Okay, don't go beyond -6, it throws index error. Okay, let's run a small a small example to understand all these characteristics. So name this file as list demo. Okay, you can add it to the Git, not an issue. So here, this is the list collection. As per list, these are the characteristics, right? So we are going to test all these characteristics. Let's apply this and see. Okay, so what is that I'm going to test now? I'm going to test these characteristics and see that. So this is the multi-line comment. Suppose if you want to describe something about any election or any scenario, multi-line is always the best practice using multi-line comments. Now let's create a list. Okay, so I can just create a list 1 equal to meaningful names is always good to have. So you can say like 1, 2, 3, 4, 5. This is collection of integers. If you want, you can add a string inside list. If you want, you can add a boolean inside list. Okay, true, and then you can add a complex inside this 20j. And this proves that this list is immutable. Sorry, I think I mentioned something wrong. This proves that this list is heterogeneous. Heterogeneous. Okay, I was about to say heterogeneous. Okay, that's the correction you can see here. Now you print it. Okay, and then let's see. Let's run this. So when I print, oh, sorry, that is actually list means you are printing list class so that you got this. Okay, no problem. Print list 1. And you can see that list is happily printed, and you can see all that heterogeneous data inside list. You can see integer, string, as well as boolean and complex type. That proves a point that list is what? List is heterogeneous. Next, second thing, it is mutable. Suppose I have list 1 of some 0, I set it with 100. If not 100, you set whatever value you want. Now again print list. After you modify that list here, the value in 0th index with 100, let's print it again. you can see that in the second output that 1 is replaced with 100. That proves this is mutable. Okay, second thing. And third thing, dynamic. I already created a list. You can see that here with how many values. Suppose if I don't know the length of list, I can simply say print. I can use a length method, which we applied even in string class. Same thing we can apply here, list of length 1. Sorry, length of list 1. You can see that it's showing 8. So that proves we have 8 elements in the list when you say length of list 1. Now suppose I want to add something. Dynamic means you can add value anytime, you can remove value anytime from a list. So what is that I do? I simply say, don't worry, you don't need to and don't care to understand what I am doing right now, except remaining other things other than append. We talk about everything in detail. Now I say that list1 dot append of some 1000. I'm adding a value, right? Sometime later, once that data structure is created. I say that list1 dot append. The question is, will this value is added to the list or not? So adding value to a list. This is possible anytime in list data structure because list is dynamic. It is growable and shrinkable. So what I do after appending a value, appending in sense adding element at the end of list, that is meaning of append, right? And I'm printing it again. Let's run it. You can see that 1000 is added into the list. That shows that list is dynamic. Okay, I'm just only talking about trying to test every characteristic of this list collection. Is it dynamic? Hence proved that. What is it proved? List is dynamic. We will play around so much today and tomorrow on list so that you get too much of idea of this list. For sure, I'm very sure on that. Okay, you get a bigger picture about list collection. Insertion order. Insertion order is preserved, right? You can see in whichever order you are adding elements, in the same order we see the output. You can see that. Nowhere you can see that change in insertion order. Because all sequential data structures preserve insertion order. They don't provide random, insertion of elements. Okay, so you just keep this point in mind. For sequential data structures or data structures which has indexing, they don't generally alter that order of placing elements. They don't make any change to that order. That insertion order is preserved in sequential data structures. Just keep that in mind. Okay. Now after that, we did tested if it is mutable or immutable, if it is dynamic, if insertion order is preserved. All these are tested. Just duplicate one, we need to test heterogeneous, homogeneous. It's clear proof that we are trying to add heterogeneous elements and hence proved we are able to print and see them. It is interpreted, they didn't throw any error. And the last scenario we should test for list is, what is that? Duplicates. So you do one thing. You can take another list instead of modifying the same one. You can take list 2. And you can take 1, 2, 3, a list of values, 1, 2, 3, 1, 2, 3. Now you can see that this list has duplicates, right? 1, 2, 3 is repeated. It occurred for twice. So what do? You can print it, print, and see that if these duplicates are preserved or removed. Preserved means allowed, removed means filtered. Let's run it now. Now you can see that they are just happily there. Duplicates are allowed without change in the insertion order, any change in insertion order. You can see that they are kept as is. Hence proved what is that? We did tested all these characteristics of list. It is mutable, it is dynamic, yes. It preserves insertion order, yes. Allows duplicates, yes. The last scenario talks about allowing duplicate values. And heterogeneous. Definitely this is heterogeneous because we see that we are able to pass different types of values into this list. Unlike bytes, if you try to pass any string or anything, immediately it raised error. But list don't have such problem. Okay. So of course, it is the nature of collection or data structure. It's not like they have any issues. They are designed such a way. Sorry. So that's all about what is it, friends, about list, introduction to list. Interesting, right? We'll just work on a couple of more scenarios and then we will close this. We will end this session today. Okay, what is that? So now reading values from list. So there are different ways of working with a list. Especially we can read generally values in two ways. Either with indexing, extracting each value. Second thing, by iterating these collections using iterating, okay, using for. I told you, right? Most of the time, we don't see while working with any kind of scenarios or programs in Python. We rely more on for because for is very much suitable to iterate over these collections. Okay. And most of the time you play around with this kind of huge data in Python. Right. So now I don't mean we completely avoid while, but there are certain few cases where we might use it. But majority of the times we prefer for over while. Now extracting each value from a list. How do you do that? Something like list 2 of 0. This gets a value from 0th index, which is nothing but 1. You can just print it here. Similarly, if you want, you can print more till that end of index. Don't go beyond the index, either negative side or positive side. So now list of 1, list of 2, okay, blah, blah, blah. So now you can print and see. This is how you extract each value from a list. Right click and run this. Now you can see that. Sorry, you should get one by one, not this. This is not the output. You don't get any output, of course. Why? Reason is simple. I just said list of that thing, but this is a batch program, right? We must use print in batch programs. Don't go without print, okay? Add a print and pass that list to print. What is the, I miss printing them, okay? Just print and print it. Now you should see that output from each index of this list 2. The first 3 indexes, 0, 1, 2, you can see that. And here it should be 2 and 3. Of course, I didn't modify these results beside this. Okay. So this is overall idea of extracting value from a list using index. Iterating. How to apply iterator on this data, list data structure. Simple, right? Iterating a list. Iterating a list. Okay. You can simply try this for value in list. Where is that? In list 2 or list 1. It's up to you which one you want to iterate. Suppose if you want to iterate list 1, choose that. This is the syntax of for, right? What happens? Always this place we have to pass a collection, any data structure. It's not like it should be only list. It can be any data structure. This is a dummy variable. Right? Every time loop iterates, one value from this collection is copied to this dummy variable and you just print it. Okay. And we did discuss this number of times. I'm just only quickly I just revising that thing. Okay. Now you can see that all values from list 2 are printed element by element or value by value. You can see that now it started with 100 and then 2 and all that. For better readable output, you can just add some description after in each print statement. That makes more sense to the output. It's up to you. Okay. So finally, you can see that this is how you iterate over a collection. Okay, using that for loop. I hope this is clear for all of you. You can also test this. I'm just sharing in the chart. Okay. Let me put it in the chart. I'm sorry, friends. So finally, what is it? So we did understand bytes. We did understand byte array, and we did understand list. Finally, there is so much of common in between all these data structures. Is it or not, friends? We can see so many similarities between bytes, byte array, and list. The difference is, let's just summarize in the notepad. What are differences we see here? I'll use this more than that. Okay, let me just show you. So suppose if it is bytes versus byte array versus, and just a quick summary, that's all. I don't take much time, and list here. What are common features you are seeing? All these data structures have indexing. Yes, right? All these data structures, bytes or byte array or list, have indexing for sure. Both forward, I mean negative and positive indexing. It has negative and positive or vice versa. You can name however positive or negative indexing, which we call forward and backward indexing. Okay, so that is common among all these sequential data structures. Right, so that is one thing. Next, after that, what else is common? So especially extracting data. So the way we extract data from all these data structures. So let me just show you. Extracting using just a minute. So I think it's okay. So extracting data. So generally, all the sequential data structures we can extract with index. Each value from that data structure through index. That is the common practice we can apply on all these collections. Okay. Of course, from here onwards, there are many differences. What is that? So mutable and immutability. So the common thing between byte array and list is byte array list is both are mutable. We can modify them. But whereas bytes is, what is this bytes? Bytes is immutable. We cannot modify it. Okay. So that is other difference between which one? Bytes, byte array and list. These two are a bit similar. Where in terms of this scenario or characteristics mutable. Next after that. Again, heterogeneous nature. Both bytes and byte array are homogeneous, okay, because both are almost similar. These are homogeneous. Okay, but whereas a list is heterogeneous. List accepts different types of data. And we have just observed that with a program. Heterogeneous. So that is other differences. These things you have to keep observing so that it gives you a bigger idea while implementing any automation or development. Okay, insertion order. Another common factor among all this is any indexed data structures, so which are common. Insertion order is preserved among any sequential data structures. Insertion order is preserved. This I am adding to the common characteristic. These are common among any sequential data structures, and uncommon means something little difference. It's showing difference that we are keeping here. In any sequential data structure, they have indexing, that is for sure. And we can extract data using index like this. And iteration is also possible. The way we iterate any sequential data structure is almost same. Iterating over collection. That is also a common thing. We don't see big difference in that. Okay, uncommon, if it is mutable or immutable, and if it is heterogeneous or homogeneous. This will have some differences for sure. And the last thing is dynamic or not. So definitely another common, I mean important feature is dynamic nature. So generally, among all this, list is, we can say that the most dynamic data structure. That's all. Because for bytes and byte array, they have a limitation. We cannot have a byte array more than 0 to 256. That's for sure. But for list, it is unlimited. Just to show you, let me just run a small program to give an idea. I use a range function here for testing this scenario for some value in range of, okay, I put some, how many zeros? Let's just stick to 10,000. Okay, don't try to, you can see that not 10,000, I am adding 10 lakhs. Okay, what is that? So how many zeros are there? 1, 2, 3, 4, 5. I put 6 zeros. Okay. And then I'm saying list to dot append of value. Just see that. Don't try to understand anything here. I'm only just showing you, and finally print it. Okay. Print list to, just to demonstrate a scenario that how dynamic is list. Anyhow, we just remove that after that. If we don't want that data, we can just remove it. Now, if you run and see this program, if you want, you can print also, right? Adding all that 10 lakh elements into the list. You can also observe that if you want by printing that value from the iteration. Now, if you run this, you can see the dynamic nature of list. You can see that it's adding so many values into that list. You can see there. Going on. And you can see that 10 lakh elements added into that list. 10 lakh, yeah, definitely 10 lakh elements, of course. It's huge data. That shows the dynamic nature of list. You got it. This is interesting, right? It's not just 10 lakhs. You can add a crore or more, or we don't have a limit for this list. Such is the nature of list here. Understand that. Okay, but anyhow, we don't need this. I just only use this scenario just to show you that how dynamic this list is. So this is having, what is that? List is definitely dynamic, but others are having limitation, including tuple. Okay, we can add how many ever elements we want into a tuple, but still we cannot dynamically keep changing tuple data structure like how we do it for list. So even the tuple thing, of course, we talked about tuple after list, but just giving a quick thing. Tuple is also immutable and we cannot dynamically grow it. So, and it's not dynamic. So we cannot dynamically grow or shrink it because we don't have methods to add or remove elements into tuple. But we have that for list. So these are all important observations or the characteristics of all these data structures. Interesting. By now you should be very clear because I repeated so that all that important fundamentals get stored into your storage. Memory storage, what I'm saying. By now you should be very clear with all this, that these sequential data structures have indexing. We extract data through index. Okay. And all these sequential data structures preserves insertion order. And we can also iterate these collections over, okay, using any loop. You can also apply for here. It's not like we should always use for. Sorry, we can also apply while. If you want, you can use while and iterate this data. That's also possible. Suppose, let me show you. Don't think that we can iterate these collections only with for. We can also apply while. You can see while I can just pass list to colon and then I just say that print. Of course, the problem is easily we can just pass it. Suppose just print hello and run this. Okay, let's run this. See the last output. Okay, it's going into infinite loop. I understand this, why it's going. I'll just fix this. I tried until that end of loop, it iterates. It's going to the infinite. What I can do is this needs initialization sum I equal to 1, and then the condition. If length of some list 2, okay, what is the length of list 2? It might be something. So the condition I should use is I less than or equal to length of list 2. Then, okay, what you have to do, till this condition is true, you should iterate that. And finally, what you can do, you can print list 2 of I. And this indexing, you set it to 0, don't set to 1, because by default, the index of any of the sequential collection starts with 0. And at the end, increment this I plus equal to increment this I. Now you print it, and you can see that, oh, it is not rendering list 2. I put it as again list. List is a built-in class. Okay, that's why it's just showing that output as is. This time it will render that output for sure. You can see that 1, 2, 3, 1, 2, 3. So just an FYI for all of you, it's not like we can iterate data only with for. You can also apply while if needed, but you can see applying this seems to be more simpler and easier. And this seems a bit, what is that? Not too difficult, but this needs a bit of more requirements. So which one, by looking at the both scenarios, which one do you prefer? If it is me, I prefer for over while, but if it is you, it's up to you. Okay, you can make a decision. Okay, that's why generally, as far as most, it makes our life easier. We choose for over while, that's all. But the idea is, it's not like to iterate, I should use always for. Okay, sorry. Yeah, I should use always for. If you want, you can use while. But again, instead of choosing a simple and easiest road, you are choosing a road that is a bit, right, uneven and it's not smooth. You got it, friends? So that is overall idea of what is that all about different collections. So what differences do you have except this? Except this byte array and list? Both are mutable. Bytes and tuple are immutable, so we cannot modify them. And homogeneous. This byte array are homogeneous, and list and tuple, they are heterogeneous. Both are heterogeneous. We don't have a problem. Among all this, the only data in this sequential data structure, string and this list are dynamic. Remaining all has a limitation. Even though these are dynamic, bytes and byte array, we can store data till 0 to 256. And tuple, even that is immutable. We cannot modify. So the most dynamic data structure is list. That's the overall idea of what is that this thing. Understood, friends? Any questions so far? Any questions? So that's idea about all this thing. Tomorrow we